A patient is set up on 2 IV medications. The first is a painkiller, and it's set at 12 milliliters per hour. And the second is a saline solution, and it is running at 18 milliliters per hour. So we have a painkiller and this solution. A doctor has asked you to decrease the painkiller by a fifth and increase the saline solution. So increase the solution for hydration purposes by 25%. What are the final flows of medication? And we want to round this to the 10th if necessary. Okay. So let's write down these givens here. So we know that we have 12 milliliters per hour. This is the painkiller. And we have 18 milliliters per hour. And that is the saline solution. So this is a decrease and an increase question. So I always like to draw these out for myself. So I start with 12 milliliters per hour, and I know that I am supposed to be decreasing this painkiller by 1/5. So that means decreasing, that is 1 minus 1 over 5. And now remember, so that this 1 right here, it means 100% of the total minus a fifth. So that's what that means. And we're supposed to be decreasing this. So that's the first one. Now the second one that we have, I'll write this on the right-hand side. We have 18 milliliters per hour. And for this one, we're supposed to be increasing this, so by 25%. Notice this is a percent, so I change it back into decimal. The previous one, so this one right here, I didn't have to change because it's not a percent. Okay, it's already a number. So coming back here, so this is going to be 100% minus 25%. So as a decimal, that's what I have. And I am supposed to be not decreasing this, but increasing. So this is positive. So this is increase. And this is negative because it is decreasing. Okay, so the arrow up and the arrow down. Now, in both situations, so I have, so let R, so that's going to be my rate. And I'll just put a little P just to say painkiller. So let R subscript P be the rate of the painkiller. And then I'll define the second one. Let R, and let's say S for saline solution, be the rate of the solution. So now solving this, I have, so RP is equal to, so notice that I will just simply follow the path. I have 100% minus a fifth. 100% is just 1, and that's supposed to be times 12. So I can solve for that. So I have, so 1 minus, and 1 over 5. Okay, so you can check for yourself. This is actually 0.2. So I will input it as a decimal multiplied by 12. And that gives me 9.6 milliliters per hour. So that is the new flow of that painkiller. And now on the opposite side here, so I'm going to do RS of the saline solution, and that equals, we're supposed to increase that. So it's right there. So plus 0.25. So again, 100% increased by 25% of the original amount. And that equals, so 1 plus 0.25 in brackets times 18. And that's going to be 22.5 milliliters per hour. Okay, so let me just check. They want this to the 10th, and they're already actually to the 10th. So that completes this question. Okay, thank you for watching. I hope you found this useful.